This is Ross, aka Dread Pirate Roberts. He was the mastermind behind the Silk Road website that sold illegal goods and services on the dark web. After monitoring his presence on the web and getting tips from whistleblowers, the FBI finally confronted him. After getting a hold of his personal computer, how were they to prove that he was indeed engaged in illicit crypto transactions? Now, before I answer this, let's have a look at the bigger picture. Even 6 years later, Bitcoin remains a nascent technology and an unregulated marketplace. It is estimated that about one fourth of all cryptocurrency traders are engaged in illegal transactions to some extent. As of 2020, illegal activity accounted for over $10 billion worth of cryptocurrency traded. If an investigator had the means to assume control of a user's wallet and transaction history, it would aid in the process of gathering incriminating evidence. Enter BlockBusters!
BlockBusters uses memory forensics to recover artifacts from crypto wallets and link an individual computer to blockchain transactions. We realized traditional disk forensics will not work here as crypto wallets encrypt their keys on the file system, but in volatile memory, keys must be stored unencrypted for the wallet to function. The plugin recovers the public and private key pair, which is used in conjunction with the blockchain search engine to isolate suspicious transactions and also seize funds from the crypto wallet. All right, so now I'll be demoing the project. On this side of the screen, you can see the backend of the crypto wallet. It's implemented in Python, and I just took the memory image of the system. So you can see that it's saved to 5432.bin. And now I'll be executing the plugin that we wrote on this. And what it's doing right now is it's finding the start of the garbage collection generations. And this is the doubly linked list that keeps track of all objects collected by the garbage collector. And this includes the public and private keys, which we are trying to find here. So as you can see, it's iterating through, and we located the private key and it printed out the dictionary. So after it reaches this, it walks through the pointers in the struct and it reaches the raw byte form and it serializes it to a readable form like so. And now the investigator has the public and private key, and he can use a blockchain search engine to find the exact transactions that the perpetrator conducted. A big part of forensics is developing a deep understanding of the underlying software before writing any code. We ran into difficulties understanding the implementation of elliptic curve cryptography and cryptocurrencies. Also, crypto wallets are commonly implemented in Python, which is interpreted to C++. So we had to read its source code and understand how native data structures are stored in memory.